Welcome back, students. This is the session 2 from the playlist of Heat and Thermodynamics, and the topic is ideal gas versus real gas. So, before taking up the topic of ideal gas equation, I thought it wise to give you a brief description about the basic difference between the ideal gas and the real gas. So, here I have written 5 bullet points which are the main, or you can say the most important basic difference between the ideal gas and the this real gas. So the first point here is, what is an ideal gas? It is an hypothetical gas. Hypothetical gas means that this gas does not exist in nature. So it is a hypothetical gas which does not has a fixed volume, whereas a real gas is a gas which has got a different volume and it exists in reality. That is, the gases which we see around us are the real gases. Second point is that in the case of ideal gases, there is no intermolecular force of attraction or repulsion between the molecules. Whereas in the case of real gases, the intermolecular force of attraction or repulsion between the molecules is present. Third point, the particles in the case of ideal gas, they undergo elastic collision. Elastic collision means that is the total kinetic energy before and after the collision remains the same. Whereas in the case of real gas, the particles undergo non-elastic collision, or we can say that here the kinetic energy before the collision is not the same, is not equal to the kinetic energy after the collision. Fourth point, and this is the important one. These two are the important point which I think everyone should very well remember. The first, so the fourth point is, it may behave like a real gas at high pressure and low temperature. That is, ideal gas may behave like a real gas at high pressure and low temperature, whereas a real gas may behave like an ideal gas at high temperature and low pressure. Last point, the ideal gas obeys the ideal gas law, that is PV is equal to nRT. This is means we will be discussing about this ideal gas law in the next session. Here the ideal gas law is PV is equal to nRT, where P is the measured pressure, V is the measured volume, N is the number of moles of the gas, R is the gas constant, and T is the temperature. Now the real gas follows this gas law, which is given by, in bracket, P plus A n square divided by V square, this is in bracket, multiplied by, in bracket, V minus NB, which is equal to nRT. So here A is basically a constant which is gas specific, and it measures the force of attraction between the molecules. And N, as you know, this is the number of moles of a gas. Here B is the volume correction factor, P is the measured pressure, V is the measured volume, N is the number of moles of the gas, R is the this gas constant, and T is the temperature. So the real gas follows this law, and the this ideal gas follows this ideal gas law, which is given by PV is equal to nRT. So these are some of the important differences between the ideal gas and the real gas. And in the next session, that is in the session number 3, I will be discussing about the ideal gas law. So till then, have a nice day. Bye.